Oh, don't mind me. I'm just setting up an amazing RAID array of NVMe on the new Z690 chipset from Intel. This is 16 PCI Express lanes of NVMe, thanks to Kioxia. These are tiny M.2s. This is their BGA form factor. These are great. These are low power. They're so low power they work great with like a Raspberry Pi. Yeah, they're not the fastest, but they are one of the most energy efficient and for one of the most space constrained. It's 4 of them, and we can run up to 4 of these in RAID on the Z690 platform. In fact, most motherboards in Z690 have 3, 4, 5 M.2. Our launch day coverage with the MSI Z690 Unify, that's a great board. It actually has 5 M.2 slots, 1 to the CPU, 4 through the chipset. You can run 2 or 3 really high performance NVMe as well, something like the Samsung 980 Pro. If you want to run those are PCI Express 4. You can run 2 of those through the chipset, and there's no bottlenecking because there's so much bandwidth in the Z690 chipset. But setting it up is kind of tricky. So I thought I would show you a guide that I put together on the Level 1 forums, but also walk you through some of the gotchas, because there's a couple of gotchas. Alright, so first off, really you need this if you need to create a bootable RAID volume. That means you want your C drive to be a stripe or a mirror or a striped mirror, because you can take 2 SSDs and stripe them together, well, mirror them, and then stripe the 2 mirrors and get the best of both worlds in terms of performance and speed. Of course, it's only half the total capacity. This is 4 terabytes. I would have 2 terabytes usable space, but hey, that's pretty awesome. Intel calls this virtual RAID on chip, although most of the terminology that I've seen in the 690 chipset configuration in our BIOSes refers to it as volume management devices. On the more expensive boards, it does tend to be more of a first-class experience. So on our MSI Z690 Unify, we get some pretty cool knobs and tunables. But I'm going to show you first on this relatively low-cost, not a ton of features, Gigabyte Z690 Gaming X. This is a DDR4 motherboard, but it has 3 M.2s plus the one from the CPU. And the one from the CPU, things get a little fuzzy. So in the BIOS, the first option that you see is VMD options. Enable VMD. That stands for Volume Management Device. So I have an enable-disable option. The enable-disable option is of the volume management device. Basically, it's do you want RAID somewhere on this system? Now this could be SATA RAID or it could be NVMe RAID. We're talking about either one. You don't want to mix SATA devices and NVMe, but you could have multiple pools of devices together for RAID. The other option is, do you want to enable it globally? What that means is just turn it on for every port. Sometimes you do want that, but in this case, to walk you through it so that I can give you a better explanation, I'm going to tell it not to enable globally. Now on this board, it kind of obtusely refers to it as root port BDF details. It really just rolls off the tongue. There's also nothing useful in the help text. This is something Gigabyte can fix in a future BIOS update. But really what this is referring to is the root PCIe complex resources that the CPU makes available. So this is a long-winded way of saying which PCIe port do you want to enable for the virtual RAID function. It's still just a soft RAID, but there is hardware to assist with the software RAID on the CPU, keep in mind. There's also not really a good map of like, okay, which ports on the motherboard correspond to which root ports on the CPU. That, dear viewer, is why I'm here, why I'm making the video, and why you're watching my overly long-winded explanation of what's going on. Or maybe you've skipped ahead and read the thread on the Level 1 forum if you're that type of person, in which case, please share it up, dude. Notice the last option is just straight up SATA. It's like, hey, do you want to enable these on the SATA options? Now, when you see the SATA option, keep in mind some higher-end motherboards, like our MSI Unify, which we'll take a look at in a second, have an extra onboard SATA controller, and you're not going to get the Intel RAID options from, like, say, an ASMedia SATA controller or extra SATA controller that's been added to the motherboard. So which SATA port and which NVMe port you're using actually does matter. For the first time on 12th gen Alder Lake, you can RAID off of the CPU port. Now on a lot of 11th gen motherboards, You know, they had a separate NVMe port that went from the NVMe slot to the CPU. But a lot of the time, the motherboard didn't expose or enable features for you to actually be able to use that NVMe slot as part of an Intel RAID volume. Well, on Z690, it seems like it's possible on at least some motherboards. Now, I've encountered one motherboard where it was not possible to enable the VMD RAID volume through the NVMe that's connected directly to the CPU. But on this lowly Gigabyte Z690 Gaming X, the $200-ish Z690 motherboard, it is possible. So it should be possible on higher end Z690 motherboards as well. The labeling here, 0/6/0, that's the one that's through the CPU. 0/29/4 and 0/27/4 refer to the 3 NVMe slots that are at the middle of the board. There's 2 options for 3 NVMe slots. Yeah, basically. When you fully populate all of the NVMe slots, all of the NVMe options will show up. So if you only put one NVMe in, only one thing will show up. So you can figure out which port on the motherboard corresponds to which thing in BIOS by just putting them in one at a time. Now you might think you're out of the woods. You enable VMD and you're good to go. No, it's a 2-step process. There's an option in the BIOS, in this case in the Gigabyte BIOS, it's under I/O ports and Intel Rapid Storage Technology, but you will not see the Rapid Storage Technology option until after you enable VMD and enable it for some ports, reboot and go to the BIOS again. That's like the whole CSM UEFI thing. If you change CSM and UEFI options, you have to save and exit before more options show up in the BIOS. This can be a little tricky. This is one of the gotchas that I was talking about. So you want to enable the volume management device thing and then reboot. Also confusingly, so if we're using NVMe like our Samsung NVMe, and you go down to NVMe options in the BIOS, it shows us no NVMe devices. But you can actually see the Samsung devices even without the NVMe option just as their own thing in the menu. It's basically down to, are these legacy UEFI NVMe devices, or do they provide their own option storage ROM, and which one do we use? Some BIOSes even give you the option to toggle, use only native UEFI option ROM versus the device provided option ROM, but that's not really super important for the scope of this video. Now with the Rapid Storage Technology option in BIOS, this is the part where you tell the computer how you want to arrange your disks. Do you want RAID 1, RAID 5, RAID 10, RAID 60, RAID 50, those things. Without anything special, it's giving me the options to say RAID 0, RAID 1, RAID 5, or RAID 10. So RAID 10 is 0+1 like I was talking about. This is huge because previously Intel has charged extra for a virtual RAID on chip function, which I never was able to get to work exactly as advertised, except with Intel brand SSDs. It's working pretty flawlessly here on Z690. This is what the experience should have been on Z490, Z590, the 3175X platform. Pretty much everything should have been this from day one. I guess thanks competition, because this is what a soft RAID experience should be. It's actually pretty reasonable in terms of stability, flexibility, so on and so forth. So you use this option to configure what you want. Now I've got 2 Samsung 2TB drives in here, and then I've got my Kioxia drives as well, which are 1TB. So I'm just going to create a simple RAID 0 stripe of my Samsung drives to give you an idea of how this works with, like, you know, it's going to be bootable. So the other gotcha is when you boot off of the Windows 11, Windows 10, Windows 11 install USB, it's not going to be able to see your drives. This is because the Windows installer doesn't have a driver that understands the Intel Rapid Storage Volume Management Device thingy. So you need some software. So you create your Windows 10 USB the way that you would, but you need to copy a folder of driver files, an INF and some sys files. That's a driver that'll enable Windows to understand what that is and actually install Windows. So that's the other gotcha. So where you get this software from, you can get it directly from Intel, but it's usually easier to get it from your motherboard manufacturer, although they usually lag behind a little bit in having the latest version, but that's okay because once you're in Windows, you can update to the latest version anyway, so it doesn't really matter. Now, most of the time it's labeled as like installation floppy or Intel VMD installation floppy. Confusingly, on ASRock's website, it's usually labeled as the SATA installation floppy, but it actually also covers NVMe devices that are using the VMD. But here are the files that you're looking for. So this is the directory. Look for these file names or something close to these file names. There's an INF and a sys and a VXD. This is how you know you got the right thing. You need to put this in a folder. Just make a folder on your USB installer. This is created with the Windows 11 media creation tool. I just created a folder on here for that, and I copied those files into it. And then when you're in the Windows 11 installer, there's a load driver option. You just hit that, and then you navigate to this folder, and there's only one thing. This is a much easier RAID installation process than on the AMD platform, because on the AMD platform you have to add 3 drivers instead of 1, usually 9 times out of 10, for whatever reason. But you add the driver here, and then it should detect your volume. So in our case, we created a RAID 0 with 2 2TB drives. Yes, it's showing as a 4TB drive. We're basically good to go. So from here, we can install Windows however we would on this device. It is bootable. And now we can install and update our Intel volume management device drivers. So don't just leave it in this state once you get Windows installed. You actually want to go install the regular drivers, probably from the Intel website, for the Intel RAID stuff. You can also get the storage thing from the Windows Store. Intel's kind of moving everybody to having the client management utility thing in the Windows Store, so you can download it from that. But you're basically good to go as far as RAID goes. Now, the really cool thing about this volume management thing is if you do run Linux, this thing is basically detected by Linux MD, which is Linux's soft RAID, and it will take the parameters that the Intel volume management RAID thing uses and use that as the basis for a Linux MD RAID. This works pretty well with like the Fedora installer and the Ubuntu installer, but I'm not really sure about other distros. I have run into problems on some other distros in the past not picking up the Intel created volume management devices. So if you get stuck, let me know. I'll try to help you on the Level 1 forums. On our MSI motherboard, it's actually a little easier. The BIOS options for configuring this, I think, are a little bit more straightforward. It actually shows you which NVMe device that you're enabling the options on in terms of, oh, this is going to be an Intel managed device. And you can have a mix of Intel managed NVMe devices and non-Intel managed NVMe devices, just like on our other system. So to recap, the gotchas are, you have to enable an option in the BIOS and then reboot, and then you can actually create your RAID array and do that kind of stuff in BIOS. That's pretty standard across every platform. It's just that not everybody explicitly says, oh, you have to reboot before you see certain options in BIOS. Like you have to enable something and reboot because it doesn't show you the extra options until after you reboot. I know, it's pretty crazy. Second thing is you actually have to create the RAID volume in BIOS. You don't have to if it's not going to be a bootable volume, but this is the easiest way for me to tell you in this tutorial. You can do it with another operating system or if you're like dual booting or something like that, but it's just easier to deal with it at the BIOS level with the Intel management utility in the BIOS. Third thing is our operating system drivers. You have to download the right thing. It's easy to go download the drivers and then just copy them to the USB and hope for the best, but I gave you the information to look for to know that you got the correct files, because there's a lot of things that fit under the umbrella of driver, but only a few things will actually work when you hit that load driver option in the Windows installer. So your mileage may vary. And finally, not all the NVMe ports on the motherboard are created equal. Some motherboards will not let you expose the Intel VMD option for the NVMe that's connected directly to the CPU. So in our case, that NVMe slot that's closest to the CPU socket on our Gigabyte motherboard, it's going to work fine. You can enable it. Totally is okay. That's not always the case, though. Sometimes you may have to run all of the NVMe that you want to RAID in the M.2 slots that are connected to the chipset. So keep that in mind. It's like, hey, I've got 3 NVMe in here. Only 2 of them are showing up. What's going on? Well, it's because it's in the CPU slot. You may have to move it. This video also kind of assumes that you have a good reason that you want to do RAID. Adding RAID to a high-performance NVMe drive can actually hurt your performance. So if you've got a really low latency, really high-performance NVMe drive, like a Samsung 980 Pro, you can have a RAID of, even a RAID 0 of Samsung 980 Pros is not necessarily going to speed things up. In fact, it may slow things down. So 2 components of speed of an NVMe is latency, how quick it's able to respond to a single request, and throughput. Once it's got a bunch of requests, how well does it handle the bunch of requests. And the Samsung 980 does both of those things really well. Some NVMe are tuned for transfer speed, so it's like, hey, this NVMe can do 7 gigabytes per second, but it's actually below par on access time and responsiveness. And if you follow this channel, it's one of the reasons we really like Intel Optane, because Intel Optane has an incredibly, just absurdly low response time. And because of that, the computer feels really insanely snappy. Generally, RAID will... Oh, it got dark. Generally, RAID will negatively impact that response time. So keep that in mind. You need to do some before and after tests to make sure that RAID is actually good. It's sort of a fun experiment. All right, I'm Wendell. This is Level 1. I'm signing out, and you can find me in the Level 1 forum.